Our final lesson in Chapter 8 brings us back to 8.2. We're going to take a look at what graphs of rational functions look like. Now in this lesson, we originally were going to do reciprocal and rational functions. We're going to stick with mainly reciprocal functions just to get an idea of what the sketch of each graph might look like. Taking a look at some graphs that are already created, what do you notice about each graph? In our first function, f of x equals 1 over x. This graph is known as a reciprocal function with x in the denominator. Recognizing what we've talked about all along in Chapter 8, that's going to give us a restriction in our domain. For the domain, recognize that x can't equal 0. And as we look at our graph, that's going to represent a vertical asymptote line. So you can kind of see that neither of those red kind of curves are going to cross over that blue line. But also notice in the other direction. We haven't had one like this before. The graph doesn't seem to cross over this axis as well. And that's because the output would never equal 0. No matter what you plug in for x to try to figure out what your output would be, if you have 1 divided by a number, it'll never equal 0 for your output. And that is the range. So the range is something we haven't done a whole lot of work with, but in this kind of graph, the f of x, the output, also can't equal 0. Important things to note as you look at the graph itself. Notice the curve is over here in quadrant 1, but it's not graphed in quadrant 2. It's also in quadrant 3, but not quadrant 4. So if you're sketching this out on your paper, you can just kind of do a curve here. This is really the basis of what we're going to cover this year. In honors functions and trig, you'll do much more work with these types of rational and reciprocal functions. When the graph of the shape of the graph is in quadrants 1 and 3, we'll know this is true because of our top coefficient. That number is positive. That's our a value. So a is positive in this picture. Now as we look at the next graph over on the right-hand side, you'll notice kind of a different shape or a different location to the shape of that graph. If you change the coefficient out in front to be negative, I have g of x equals negative 1 over x. Now notice the location of the curves. It's in opposite quadrants. It's in quadrants 2 and 4. And that's because your a value is negative. So write that down. And then recognizing the domain and the range. Again, even though it's in different quadrants, it's still going to approach that vertical asymptote when x equals 0. So as a domain, we say x can't equal 0. And for our range, again, it can't cross over that y-axis right here, the x-axis, and that means that our output, or g of x, can't equal 0 either. There are ways to move those two asymptote lines, and that's going to come with transformations on these reciprocal functions. Let's take a look at this last graph that's drawn for you. H of x equals 2 over x minus 4, plus 4 minus 3. So 2 over x plus 4 minus 3. The 2 is going to do something to the shape of the graph. The x plus 4 does something to the shape, and the minus 3. They all have an impact on what this graph looks like. What I notice right away is that I see where that negative 4 is on the graph right there. Do you see how that curve kind of goes all the way up but doesn't cross over it? And then even at the bottom, same idea. That's where our asymptote line is going to be. So we kind of draw that boundary line in, recognizing that in the denominator we've got x plus 4, and we know that x can't equal negative 4. So that means that blue line is that vertical asymptote, or that boundary. But now notice kind of horizontal. You see the graph kind of even out as it goes over to the right, and then over on that left-hand side, somewhere between 2 and 4. So if we draw a line so that we don't cross either of those, it's going to go right through at negative 3. And that comes from what's being subtracted after. That has an impact on our range. Here, h of x, whatever we plug in for x, we'll never be able to get an answer that equals negative 3. And that's in part because we can never plug in a value for x that makes that fraction cancel out, so that negative 3 is left over. But now let's talk about what that 2 does. As that number in the top of the fraction gets bigger, the graph gets more stretched and stretched apart. So if we kind of zoom back out to see all of our pictures, the graph on the very right, because of that 2, is stretched out further than the graphs when the a value at the top was a 1. So the bigger the a value, that number that's on top, the more spread apart these graphs will be. Our main focus will be to look at domain and range, and then just doing a quick sketch in the appropriate quadrants. Last but not least, I'm going to zoom. Whoa, sorry, that got a little crazy. We're going to zoom back in here. Notice how when we create those x and y asymptote changes, the quadrants kind of shift as well. It's kind of like you're taking the center or the origin of the graph and transferring it down to this point down here. So because of that, as we think about what this shape's going to do, it's going to be over in quadrants 1. This would be like the new quadrant 1 over here, and then all the way down here in quadrant 3. And that's because that 2 is positive. All right, let's see if we can sketch some graphs on our own. As we take a look at that general kind of template, f of x equals a over x minus h plus k. The descriptions for the x minus h and the k and even the a value are consistent with all the types of functions that we've done transformations on. They're consistent with quadratics, they're consistent with cubics and quartics, all those kinds of things. Even with the square root functions that we talked about back in chapter 6. If you look at that lead coefficient, whether a is on top of the fraction or you have a number out in front being multiplied to that fraction. If a is positive, that means the graph is going to be sketched in quadrants 1 and 3. And the bigger the a value, the further and further apart those curves will go. If a is negative, it just flip-flops and it's in quadrants 2 and 4. That x minus h value is going to change the domain because it's going to shift it in the opposite direction. So we have to make sure that we kind of can accommodate where that x minus h puts the domain rule. And then last but not least, the k value, whether it's positive or negative, will change the range restriction. So as long as we can kind of keep those things in check, the sketches for these graphs should be pretty straightforward. We're just going to sketch 2 quick graphs. It says state the domain and range for each graph. Sketch the asymptotes. It says then make 2 tables to sketch the graph for each function. We're just going to do the sketch of the graph. So we're not going to make 2 tables. We're just going to kind of sketch it based on what we talked about up above. Let's take a look at example A. We start off with y equals 5 over x minus 1 minus 3. As we think about x in the denominator, consistent with all the x's we've worked with up to this point in chapter 8, we know there's going to be a restriction on the domain. X can't equal positive 1. So for that graph that we're going to plot, the asymptote, we actually graph that at x equals 1. That's just going to be a vertical line. The plus 3 is going to move everything on the y-axis down 3 units, and that's going to be a restriction on our range. Now the output is y. We know y won't be able to equal negative 3, and that's what our asymptote will do. I'm just going to abbreviate that. We know that y equals negative 3 is our border of that boundary line. Now a equals 5, and that's a positive number, so our graph is going to be in quadrants 1 and 3. And 5 is bigger than 1, so we're really going to stretch the shape of this graph. Now literally we're just going to be very kind of broad with this sketch. We're not going to be super specific. Go ahead and draw your x and y axis. Now if I have to go 1 to the right for x, I'm going to draw that in and then draw my vertical asymptote. Like so. That's x equals positive 1. And y can't equal negative 3, so I'm going to also drop down to negative 3, like so, and draw my horizontal asymptote right there. That's at y equals 3. So it's like we're shifting our graph just kind of to the right and down a little bit. And now recognizing because a is positive, we're going to be in quadrants 1 and 2. Whoa, 1 and 3. There we go. 1 and 3. Now usually the curve is pretty close to where they intersect, but 5 is going to be a little bit bigger. So watch this. I'll plug in a point for you just to give you an idea. If we can't plug in 1 because that's the asymptote, what would we get if we plug in 2? Well, 2 minus 1 is 1 in the denominator, and 5 divided by 1 would be 5. 5 minus 3 is 2. So if I go 2 to the right, and up to, that's going to be a point on my curve. And then it's going to start to taper off. So what my graph will do is it'll get close to that vertical asymptote, but then start to slowly make its way over to the right. And if we go in the other direction, well, if x can't equal 1, what if I go 1 to the left and say that it can equal 0? Well, then 0 minus 1 in the denominator is -1. And -5, or 5 divided by -1 is -5, minus 3 goes all the way down to -8. So I'm writing down 3, and I'm going to go 4, 5, 6, 7, 8. It goes through that point. And again, it gets really close to that vertical asymptote over here, but then starts to kind of level out as it makes its way towards the orange asymptote. And that would be the sketch of that reciprocal / rational function. All right, for our last example, my cat Harley has decided to help me create the video. So if you hear a weird purr sound, that's just Harley sitting on my lap. All right, we have f of x equals -1 times x plus 5, or divided by x plus 5 plus 4. Again, as we think about what have we done so far in this chapter, we know that we create a restriction on that domain, and that would be x can't equal -5. And then that plus 4 at the end, anything that's being added afterwards is going to have an impact on our output. Based on this equation, our function will not have an output of +4. Notice at the top, a is 1, but technically it's -1. Let's get that circled. So our a value is negative, and that's going to indicate you're in quadrants 2 and 4. So our curve will go in opposite directions from what they did before. And that -1 is going to indicate that it stays pretty close to where our asymptotes cross. Again, writing in if that our asymptote, I forgot to add that. Let's add that now. Our asymptote would be x, oops, sorry, whoa, can't equal, but the asymptote is x equals -5. See, Harley's distracting me. All right, for the vertical, or the horizontal asymptote, seriously, being distracted, we're just gonna write y equals 4, because on our graph, we just use the x and y coordinate system. All right, that being said, let's take a look. So we're gonna go 5 to the left and up 4. So our graph is gonna be kind of, I'm gonna go like this a little bit. So knowing that I have to go all the way over to -5, I'm going to go 1, 2, 3, 4, 5, and draw that vertical boundary, that vertical asymptote. Whoa, not even close. Sorry guys, hang on. There we go. Let's try that again. Get a little bit closer to the 5. Maybe. Let's see if this is any better. Oh yeah, oh, I'll take that. Even my graph is crooked. All right. For the y's, we'll go up to 4. So I'll count up 1, 2, 3, oops, 1. Yeah, there we go, 4. All right, now we'll go across. Yeah, we'll get there. No worries. There we go. You'll notice that our coordinate system kind of shifted to the left and then up. All right, so to figure out what quadrants we're in, quadrant 2 is now going to be over on this side. It's kind of stretched over here a little bit to the left. And then quadrant 4 is kind of this whole section down here. Even the x and y axis are included in that quadrant. All right, to think about what we could just kind of test our waters to see what we can plug in, always use that vertical boundary. So if x can't equal -5, I'm just going to go 1 to the right and 1 to the left. If I go to -4, let's take a look at our order of operations. -4 plus 5 in the denominator is 1. And 1 divided by 1 is 1, but remember there's that negative out in front. -1 plus 4 is 3. So if I plot -4 up 3, notice my point is in that quadrant 4. Now this curve is going to be a little bit more kind of following right along those asymptote lines. We'll curve it up from the bottom right here, and then once it hits that point, it's going to kind of curve way over here. Sticks pretty true to those asymptote lines on each side. Now if I think about going to the other side of that vertical asymptote, I'm going to go to -6. So I'm going to go over here, just 1. Whoops, that's a little too far, but we'll make it happen. All right, if we do -6 plus 5, we get -1. And then that fraction becomes 1 over -1, but then the negative out in front makes it +1. And 1 plus 4 is 5. So if I go to -6, we're actually going to go up over into that other quadrant, into quadrant 2. Again, following the shape of those asymptotes because we're already really close to that, and then curve, and then it goes right towards that other one with arrows on each side. And that's it, everybody. Those are the equations or the sketches of the graphs for reciprocal functions, and more specifically next year, you'll look at rational functions.